Hey everyone, either welcome back or welcome to my channel. Hello. So in today's video, this is going to be my science video for the week. It's going to be a little bit different. How biochemistry has really opened my eyes in more ways than one, and how learning about a topic in science can really actually humble you. Hello everyone, and welcome to my world. So 2018 was the best year of my life, but it was also one of the hardest years of my life too. It was the best year because I finished my bachelor's degree in biochemistry, but I was also diagnosed with a rare condition called idiopathic intracranial hypertension. So if you're curious to learn more about what it's like to live with idiopathic intracranial hypertension and or also apply some of the basic concepts that you learn in biochemistry at the undergraduate level, then I encourage you to watch on. The more I learn about biochemistry and different things that revolve around biochemistry, whether it be genetics or molecular biology, things that I really enjoy, the more I realize just how much we don't know about the topic. As somebody who has been through quite a difficult diagnosis, going through what I went through to be diagnosed with idiopathic intracranial hypertension, the videos that I do on Mondays, I can really relate to this in an interesting way. And I appreciate a lot when I hear from my doctors that they don't know something, instead of just making something up to answer my question and make me feel like they really know something. It actually makes them sound more intelligent when they say, "Oh, I'm not sure. I can actually look that up or I can find out for you, but I don't really know that right at the point in time." I love hearing that. Now, I want to target this from a biochemistry perspective too, because on exams, you're punished for things that you don't know. But the point of being a student is to learn. You learn not only by making mistakes, but you learn by not knowing information and being guided to the right information. The biggest thing when it comes to science is the fact that we are good. We are okay when something changes, or we should be. This isn't always the case, but science is a process. And what we know now as truth may not be held equally 5 or 10 years from now. There are certain things, as I said in the fact versus theory video, that have kind of been replicated to the point where, okay, can we stop talking about this? An example I can give you for this right now is vaccinations. It's very clear that there is no link between MMR and autism. So we need to stop putting our money towards this stuff and actually start to try and decode what might be going on with autism. There's a lot of things that could be correlated with an increase in autism. Just look at the last 50 years, and anything that's increased in the last 50 years could really be correlated with an increase in autism. And it may not even be that autism is increasing. It really could be just we're getting better at diagnosing it. The concept of it's not possible to understand everything. This also goes in between different areas in science. So as someone who is trained in biochemistry, and actually I know nothing about plants. There's actually a whole different realm of biochemistry that is actually plant biochemistry. And because my department was based out of the College of Medicine, I learned specifically on topics specific for eukaryotes, but in particular we were given examples with human body and with medicine. So it's kind of been interesting actually, because it's almost like studying medicine as an undergraduate, but not really, because my degree isn't from the College of Medicine. So I actually describe a little bit about that when I talk, I think, in my Why I Did Biochemistry video. I can link that above if you guys want to check that out, Why I Did Biochemistry. It's kind of related more to this personal kind of science content instead of the more of the, proteins or fact versus theory kind of thing that I've already done, where I've been more formal and a little bit more of a tutorial kind of thing and navigating around information. There's a difference between science and myth, is the fact that science does change quite a bit over time, and depending on the area of research and how active the research is today, it can be changing pretty fast. So today we're very, very active in things like CRISPR and genetic engineering, and drug development is another huge area of which I'm familiar with. Like I said, this is going to be focused on stuff that I learned about in school, but it was definitely interesting to read through more recent literature on things like CRISPR and genetic engineering, GMO food, and a lot of these different things. We learned how the stuff was done. So it was humbling in the fact that, oh, well, that makes sense as to why it's not as much of a concern now. Another big thing that is very important to consider when it comes to this whole thing about not knowing everything is the fact that when you're in one area of research, it's almost impossible to keep up with every single area of research. So, for example, someone who's dedicated a lot of time to studying biochemistry is probably not going to have a ton of time looking at things in physiology or other areas of biomedical science, let alone the areas of like interest in biology, chemistry, or physics. So if you get, I see this often happen with things like nutrition and stuff like that, where you get a bit of a crossover between people going from one area to another. I can see if these are very related, but actually, we've had a lot of people that have crossed over from things like they've gotten a degree in engineering and then gotten into biomedical sciences. And I just don't know how they do it, because you need to have that such a strong base in order to understand that information that you're looking at. So I don't know how they do it. I really don't. Chemistry to biochemistry, on the other hand, there's a lot of intersection between chemistry and biochemistry. Actually, it's very, very nice having a strong chemistry background for biochemistry, because you're taking that chemistry and you're just applying it to conditions in the body. But it makes sense to have a collaboration with like computer science and genetics when you're trying to do stuff like gene sequencing or stuff like that, because you need to have the algorithms work so that they can work towards kind of figuring out the best way of sequencing a genome, which they've done really, really well with that. Like I said, we're so far into this fourth generation sequencing that it's definitely worked really well. And actually, like, there's a lot of times often they'll get people who have strong backgrounds in biology to collaborate with people who are in computer science so that they can build better algorithms so that the gene sequencing can become better. So that's kind of it. There's really, really good collaborations taking place, but it's kind of difficult to understand how some people can take a certain degree in a certain area and do really well in a completely different area, but it does happen. So definitely know that just because that you take a degree in a certain area does not mean you're stuck with that for life. You can always go on to a different area. It's just you may need to work a little bit harder to catch up on your background. Don't forget to, again, like and comment down below. If you want to, definitely give me video suggestions. The next video after this should actually be our vlog. So I definitely look forward to updating you guys about that. And as for now, like, don't forget to send me a message if you guys would prefer to send me a message via social media instead, because you don't have a YouTube account. That's perfectly understandable. And as for now, that should be it. So bye, everyone.